Good morning, students. Okay, this morning, God helping us, we want to look at not symmetric matrix with repeated, the eigenvalue of non-symmetric matrix with repeated eigenvalues. The topic again, I said this morning, we want to look at eigenvector, eigenvector of non-symmetric matrix with repeated eigenvalues. That is what we want to look at this morning. And let's quickly take an example. Now, find the eigenvalues and the eigenvector of this matrix. You have to find the eigenvalue corresponding eigenvector of this particular matrix, -2, 2, -3, 2, 1, -6, and -1, -2, 0. Now, the question is what you have to find all the eigenvalues and the corresponding eigenvectors of this particular matrix solution. Now, the first thing we'll do here is what you first and foremost find your eigenvalues. And how do you find your eigenvalue? Using the characteristic equation given by A minus lambda I equals to what? Equals to 0. And when you simplify this, you have what? -2 minus lambda 2 minus what? 3. We have 2, 1 minus lambda minus 6, and we have -1, -2, and minus lambda. That this is 0 minus lambda is what? Minus lambda. Everything is equals to what? 0. And you simplify this. And when you simplify this, you have what? -2 minus lambda in brackets. Open brackets. You cover this, you cover this. You have this one multiplied by this minus this one multiplied by this. That is what? Minus lambda into 1 minus lambda minus 2 times -6 is what? Is 12, positive 12. And there is other one negative. This is positive, this is what? Positive. And we have what? -2, open brackets. You cover this, you cover this. You have 2 times minus lambda. We have what? -2 lambda minus this 1 times 6. You have what? -6. And lastly, you have what? -3. You have -3, open brackets. And you cover this, you have what? -4 minus this 1 times this, minus times minus, you have what? Plus what? 1 minus lambda, close bracket, everything equals to what? 0. And from there, you simplify through, you have -2 minus lambda, open brackets, you have minus lambda squared, plus lambda squared, minus 12. Open this bracket, you have what? Plus 4 lambda plus 12 minus 3. And the other one, we have what? Plus 3 lambda. Everything equals to what? 0. And when you open this bracket too, you have what? 2 lambda minus 2 lambda squared plus 24 plus lambda squared minus lambda cube. This one times this plus 12 lambda. This and this will give us what? 7 lambda plus 7 lambda. This one plus this is 24 minus this, that is 21 plus 21 equals to what? Equals to 0. And this will give us what? Minus lambda raised to power 3, this and this. It gives us what? Minus lambda squared x, that is 2 lambda plus x, that is 14 lambda plus this 21 lambda plus 21 lambda. This and this will give us 45 plus 45 equals to what? Equals to 0. And when you multiply through by -1, we have what? Lambda raised to power 3 plus lambda squared minus 21 lambda minus 45 equals to what? Equals to 0. Now you solve this. And how do we solve this? You can just use trial and error. And how do we mean by trial and error method? You can say this is P of lambda. P of lambda is just lambda raised to power 3 plus lambda squared minus 21 lambda minus 45. Now find the value of lambda in such a way that this whole thing becomes 0. And if you can try P of what? Minus 3. What is P of minus 3? This one becomes minus 3 raised to power 3 plus minus 3 squared minus 21 into minus 3 minus what? 45. If you try that, when you simplify this, you have it what? Equals to 0. That is lambda equals to what? Equals to minus 3 is a factor of what? Of P of lambda. And if this is a factor of P of lambda, the next thing we do now is what? We divide P of lambda by what? Lambda plus 3. Lambda plus 3. Now, let me quickly do that. The next thing is what? We divide. We divide P of lambda by lambda plus 3. And you can just use long division. We have lambda plus 3. The other one is what? Lambda raised to power 3 plus lambda squared minus 21 lambda minus what? 45. Lambda raised to power 3 divided by lambda is lambda what? Square. Lambda square multiplied by this is lambda raised to power 3 plus 3 lambda. This one becomes negative. I have what? Minus 2 lambda squared. You bring this one down, minus what? 21 lambda. Minus 2 lambda squared divided by lambda, you have what? Minus 2 lambda. Minus 2 lambda times lambda, have minus 2 lambda squared. This one times this is what? Minus 6 lambda. Okay? This one becomes positive again. Minus 21 plus 6. That is 15. That is minus 15 lambda. We bring this one down again. We have what? Plus 45. Minus 15 times 6, you have what? Minus 15. Minus 15 times 6, minus 15 was lambda. This one minus 6 times 6 is what? Minus 8. This is negative. We have what? Minus 45. And the whole thing will cancel out. And that P of lambda equals to what? Lambda equals to lambda plus 3 lambda squared minus 2 lambda minus what? 15. Okay, and since our P of lambda equals to 0, it means that was lambda plus 3 equals to 0. Lambda squared minus 2 lambda minus 15 is equals to 0. And here we have lambda equals to minus 3, or we factorize this. And what's your factor here? The factor 0, what? Two numbers you multiply to have minus 15, and when you add together, we have minus 2. That should be minus 5 and positive what? 3. Okay. And since this is this, we have lambda equals to what? Minus 3, or lambda equals to what? Positive 5 or negative what? 3. Therefore, our eigenvalue Our eigenvalues are what? Lambda equals to 5 minus 3 and what? Minus 3. That is our eigenvalue. Now the next thing to do is what? Next we'll find what? Eigenvector. Next we'll find what? Eigenvector. Next we find eigenvector. And how to find eigenvector? Remember your formula, we have A minus what? Lambda I. X equals to what? 0. Where your S is your what? Eigenvector. Now, first and foremost, what's your matrix A? A minus lambda I. Remember is what? Minus 2 lambda minus, sorry, this is what? Minus 2 minus what? Minus lambda 2 minus 3. We have 2, 1 minus lambda, I have what? Minus 6. And lastly, we have minus 1, minus 2, and what? 0. Where your S is what? X1, Y1, Z1 equals to what? Equals to 0. Now, first and foremost, we just said when lambda equals to what? 5. Now, when lambda equals to 5, we have what? Minus 7, 2, minus 3, 2, 1, minus 5. That's minus 4, minus 6, minus 1, minus 2. Sorry, this is 0 minus lambda, and that is what? Minus 5. You have your what? X1, Y1, Z1 equals to what? Equals to 0. Now, just simplify this, and this one will give us what? Minus 7 x1 plus 2 y1 minus 3 equals to 0. We have 2 x1 minus 4 y1 minus 6 z2 equals to what? 0. And the last one minus x1 minus 2 y1 minus 5 z2 equals to what? Equals to 0. Now the next thing to do, you can just take any of x. We are looking for the value of what? X and y. See that you solve for question 1 and equation 2 since it's homogeneous equation. Okay. Let me quickly draw the sides. Okay. What we'll do next now, we can just solve equation 1 and equation 2. That is minus 7x1 plus 2y1 minus 3z1 equals to 0. And the other one, 2x1 minus 4y1 minus 6z1 equals to what? 0. You can just write x over. Okay, you don't write the coefficient of x here. You have what? 2, 4, right? You have what? 2 minus 4 minus 3 minus 6. Okay, equals to y. Sorry, x1, y1, y. You don't write coefficient of y here. You have what? Minus 7, 2, minus 3, minus 6. And the last one, we have what? Is it 1? Coefficient of x, you have minus 7, 2, 2, minus 4. And you have what? X1 now over, like you find the determinant of this is 1 times this is what? Minus 12 minus, that is 12 equals to y1 over this 1 times this, that is minus 42 plus this 1 times this is what? 6. Okay, equals to z1 over this 1 times this, that is 28 minus this 1 times this is 4. And this will give us what? X1 over minus 24 equals to y1 over this one plus 6 This one times x minus this one plus this, that should be 30, is it 36? Okay, this one is that should be 36. And equals to z to 1 over this and this will give us what's 24. Okay, let me check this again. This one multiplied by x, okay, is oh, it's positive. This is positive. Sorry, this should be what? Positive. And if it's positive, this is positive. Meaning that this place is going to be what? This one plus this should be this one times this 42 minus, okay, 6. That is what? 48. And from here, we can divide through or multiply through by what? 40. Sorry, multiply through by 24. And if we multiply through by 24, we have x1 over minus 1 equals to what? y1 over 2 and z1 over what? Over 1. Meaning that our eigenvector x1 equals to minus 1 to that is our first again what? Eigenvector. Now we look for the other eigenvector. We remember in this particular question we have repeated what? Eigenvalue. Repeated what? Eigenvalue. Now the next thing we do, we look for when lambda equals to what? Minus 3. When lambda equals to what? Minus 3. When lambda equals to minus 3. When lambda equals to what? Minus 3. When lambda equals to minus 3, you can do the same thing. Okay? When lambda equals to minus 3, you come here, substitute that value again to have when lambda equals to minus 3 here, we have what? Minus 2 minus 3, and that is 1. We have 2, we have minus 1. Here we have 2. We have minus 3 is positive 3 plus 1. That should be 4. Minus 2, minus 3, minus 6. We have positive 3. And this time around, eigenvalue 2, that's s2, y2, and z2 equals to what? Equals to 0. Simplify this, you have what? X2 plus 2, y2 minus 3, z2 equals to what? 0. We have 2, x2 plus 4, y2 minus 6, z2 equals to 0. And the last one minus what? X2 minus 2, y2 plus 3, z2 equals to 0. When you look at all these questions, all the equations are what? Are the same. Okay? All the equations are what? Are the same. And since all the equations are the same, you can just take any of those equations and solve. I have what? Y x2 plus 2y2 minus 3z2 equals to what? 0. Now, how can you solve this equation since all these values are what? Are the same? You can solve it by just equating, or you can just say let x2 be what? Be t, and what? Y2 be what? X. Okay, with this now, what is going to be as Z2? Z2 is going to be what? X2 plus 2y2. Okay, this is what? 3x2. X2 now is going to be 1 over 3 into what? S2 plus 2y2. Okay, and from here you have what? 1 over 3 into, what's that? S2? S2 is what? T plus 2 y2. Y2 is what? Is x. Okay. Now from here now, you've gotten your what? You've gotten an answer for this, okay? And here you can just use the try and error. You see, this is homogeneous equation. And since it's homogeneous equation, like what I taught you, homogeneous equation will have will have what? Infinite what? Many solution. Infinitely what? Many solution. Here you can just say let t be what? Is 0 and the other one be what? Be 3. Let the t be 0 and the other one be what? 3. And we have what? Z2 equals to 1 over 3 into what? 0 plus what? This one must be right. That is 6. Okay. And this one will give us what? 2. Meaning that x2 now is going to be what? S2, that this eigenvector corresponding to lambda equals to minus 3 is going to be what? X1, sorry, X2, that is what? 0, Y2, which is what? 3, and the last one, Z2 is what? Is 2. Okay, that is the second eigenvalue. Now, how do you find the last eigenvalue? How do you find the last eigenvalue? Now listen, please, because listen, please. How to find the last eigenvector, not eigenvalue. The last one. To find the last eigenvector, what you do now is what? Remember, you can just write since the matrix, since the matrix is what? Is non symmetric. The corresponding on the eigenvector vector x2 and x3 must be linearly independent. Must be what? Linearly what? Independent. And what do we mean by linearly independent? That is some lambdas of x2, maybe lambda, okay, I should not use lambda. Let me use another letter, please. Maybe, let's say alpha 1 x2 plus what? Alpha 2 x3 must be equals to what? 0. And must be what? Is 0. And all your lambda must be what? Must be equals to what? Is 0. This one is linearly independent for what? For lambda 1 equals to what? Lambda 2 and is equals to what? Equals to 0. When lambda 1 and lambda 2 are not equals to 0 and not all equals to 0, we say that this is what? Linearly what? Dependent. But they said here that since the matrix is not symmetric, number 1, the corresponding eigenvector to the repeated roots, that is x2 and x3, must be linearly independent. That is alpha 1 x2 plus alpha 2 x3 must be equal to 0, where your lambda alpha 1 and alpha 2 are what? Are 0. Now, can you do this? You can just use trial and what? Trial and error. You can just choose. And just choose your, you can just choose and just form the what? Your, the x3. X3 now equals to, you can just choose your s3, you know, this one should be s3, this is y3, and this is what? Z3. You can just choose arbitrarily the this one equals to what? 3, and this equals to 0, and this equals to what? Any value, probably 1. Okay? Equals to what? That is your what? This is your the third eigenvector. And how can you prove? And we can see here that when when you use this, when you try this, you see that it was linearly independent. How do I mean? Alpha 1, what is your x1? Is 0, 3, 2 plus what? Alpha 2, what's your x3? 3, 0, 1 equals to what? Equals to 0. Can we try and solve this? We will see maybe they are linearly dependent or not. And when you open the bracket here, you see this one multiplied by the first one. You see that was 3 alpha 2 equals to 0, which implies alpha 2 equals to 0. And the second one, you have what? 3 alpha 1 equals to what? Equals to 0. And we can see that what? Alpha 1 equals to 0. And the last one, you have 2 alpha 1 plus alpha 2 equals to 0. And since these one are equals to 0, we have that 0 equals to 0, meaning that what? These are what linearly dependent. Now, that is the end of the solution. I do hope when we go through this and what we are going to do in class, you understand the concept much better. Thank you for listening.